Right, volume of a prism today. All right, so a prism, just to recap, so any shape, any 3D shape, where it has a cross-sectional shape that runs all the way along its height, same size, same shape, right, from top to bottom. So for a cylinder, it's a circle. For a rectangle, for a cuboid, it's a rectangle. For a cube, it's a square. Going back to what we were talking about with volume of a cuboid, volume is a counting exercise. It's counting how many cubic units you can fill inside a shape. So what's the volume of this shape? 1, 2, 3, 4, 5, 6 centimeters cubed, assuming that these are centimeters cubed. Okay. What about this shape? Well, the top layer is the same thing. 1, 2, 3, 4, 5, 6. You've got two layers. Each of them have 6 centimeters cubed, right? So the 6 in the top one, 6 in the bottom one. 2 times 6 is 12, right? So the volume of 6 times 2, which is 12 centimeters cubed. What about this shape, right? 1, 2, 3, 4 by 1, 2, 3. So our knowledge of areas of a rectangle, that should tell us that there's 12 centimeters cubed in this layer here. As soon as I put them into 3 layers, now we've got 3 layers of the exact same thing. So layer 1, layer 2, layer 3. Each of them has the same 12 cubic centimeters in them. So 3 times 12, that's going to be 36 centimeters cubed. Okay, so 12 in each layer, and that's 3 layers. 12 threes are 36. Right, now I'm not showing you the layers. Now I'm taking off the lines that showing you the layers, but I am showing you how tall it is. It's telling you it's 3 centimeters tall. That means we must have 3 layers of cubes stacked on each other because each cube is 1 centimeter, right? So how many cubes are in the top layer? 1, 2, 3, 4, 5 by 1, 2, 3. 3 5, so 15. And it's 3 tall. So we've got 3 layers of 15 cubes each. 15 threes are 45. What about this one? This is 5 centimeters tall. That must mean it has 5 layers. So we can count 1, 2, 3, 4, 5, 6, 7, 8 in the top layer with 5 layers. The volume has to be 5 lots of 8, 40 centimeters cubed. How many in this one? In the top layer, 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3. 3 eighths are 24, and there's 2 centimeters tall, so there's 2 layers to it. So it's going to be 48 centimeters cubed. We're building up this idea now that all I need to do is just find the area of the top surface, and the height of the prism is telling me how many layers that top layer has been stacked on top of each other, because that's what a prism is. It's the same shape that's been stacked on top of each other. So I've got this triangle here, and if somebody tells me that the top layer has 6 centimeters cubed, and somebody tells me that it's 10 centimeters tall, I know that there's 10 layers of that same 6 centimeters cubed. 6 times 10, 60 centimeters cubed. This cylinder, somebody tells me that the top layer has 10 centimeters cubed, and it's 7 centimeters tall. So my volume is 10 sevens, 70 centimeters cubed, okay? So this is what you need to write down, because now we have a strategy for finding the volume of a prism. Write this down: the cross-sectional area times the height. The cross-sectional area is A times the height H. This is how you write it in algebra. The cross-sectional area is the area of the top face of whatever the cross-sectional shape is, and it's the same as the volume of the top centimeter layer of the prism. That's why it's times the height. So volume is area times the height. This prism here is a star prism. Okay, the area of the star is 7 centimeters squared, and the height of the prism is 9 centimeters. Volume is area times height. 7 times 9, 63. The area of this prism is, the cross-sectional area is 11 centimeters squared. The height is 9 centimeters. Volume is cross-sectional area times the height. 11 times 9, 99 centimeters. The area of this prism, I don't even know what that shape is. Probably it doesn't even have a name. Volume is area times height. 6 times 8 is 48. Area of this hexagonal prism, the area of the hexagon is 2 centimeters squared. Height is 13. Volume is area times height. 2 times 13 is 26 centimeters cubed. Have a go at the assignments now.